maximum and minimum value of a parabola. There are two parabolas here. Let us say this is the first parabola and this is the second parabola. This is the vertex of the first parabola. This is the axis of symmetry. This the first parabola opens downward. If the parabola opens downward, then it has a maximum value. This is the vertex of the second parabola, and this is the axis of symmetry. This parabola opens upward. If the parabola opens upward, then it has a minimum value. The maximum or minimum value of a function is the y-coordinate of the vertex. So the maximum value of the first parabola is the y value of its vertex. And the minimum value of the second parabola is the y value of its vertex. Without graphing the parabola, determine whether it opens upward or downward. Then determine the vertex and the maximum or minimum value. Number 1, y is equal to 2x squared minus 4x plus 5. Number 2, y is equal to negative 3x squared plus 12x plus 2. Let us solve the first one. Y is equal to 2x squared minus 4x plus 5. This is in the form of y is equal to ax squared plus bx plus c. A is the coefficient of x squared and a is equal to 2. A is greater than 0. Hence, the parabola opens upward. If the coefficient of x squared is greater than 0, then the parabola opens upward. We are going to find the x-coordinate of the vertex. We are going to use this formula. X is equal to negative b over 2a. B is the coefficient of x. The coefficient of x is equal to negative 4. So we substitute negative 4 for b. And a is equal to 2. So we substitute 2 for a. This is now equal to negative, open parenthesis, negative 4, close parenthesis, over 2 times 2. This is now equal to 4 over 4. And 4 over 4 is equal to 1. And then we are going to find the y-coordinate of the vertex. We are going to use the equation of the parabola. The equation of the parabola is y is equal to 2x squared minus 4x plus 5. We substitute 1 for x. So this is now equal to 2 times 1 squared minus 4 times 1 plus 5. This is equal to 3. So the vertex is the point 1, 3. The y-coordinate of the vertex is 3. If the parabola opens upward, then the y-coordinate of the vertex is the minimum value. So the minimum value is 3. Let us solve number 2. Y is equal to negative 3x squared plus 12x plus 2. This is in the form of y is equal to ax squared plus bx plus c. The coefficient of x squared is a, and a is equal to negative 3. A is less than 0. Hence, the parabola opens downward. If the coefficient of x squared is less than 0, in this case it is negative 3, then the parabola opens downward. Next, we are going to find the x-coordinate of the vertex. We are going to use this formula. X is equal to negative b over 2a. We are going to substitute the coefficient of x, which is 12, for b. And the coefficient of x squared, that is the value of a, is negative 3. So we substitute negative 3 for a. This is now equal to negative 12 over 2 times negative 3. This is now equal to negative 12 over negative 6. Negative 12 divided by negative 6 is equal to 2. So the value of x is 2. And this is the x-coordinate of the vertex. Next, we are going to find the y-coordinate of the vertex. We are going to use the equation of the parabola. The equation is y is equal to negative 3x squared plus 12x plus 2. We substitute 2 for x. This is now equal to y is equal to negative 3 times 2 squared plus 12 times 2 plus 2. And this is equal to 14. Since the parabola opens downward, then it has a maximum value. And its maximum value is the y-coordinate of the vertex. The vertex is point 2, 14. So the maximum value is 14.